Get a job in tech. Episode 105. Thank you very much for listening to the podcast. And I want to continue on some of the stuff I talked about in the previous episode, which was how to get started in tech. So you work somewhere and you want to get started in tech. So I'll just put it to you this way. If you live in another country, say you're not American, let's just say, and you want to work in the United States, let's just say, you do the same thing as people do in the US. Meaning you put the resume out there and you put like in the previous episode, I think it was 102, I believe it was, where how to create a resume, right? You do the same way you have. So the thing about it is a little bit of something extra on that is that if from from India, let's say, right? See if you can't fake or develop a British accent. Okay. The reason you do that is now, of course, you're going to have to stick with it, right? Because it's going to have to be your calling card, if you will, right, for the future. But if you can learn a British accent, that would really help you go a long way, actually, because it would mask the fact that maybe your English isn't good, right? But if you just speak with a British accent, the people in the U.S. are going to look at you a little differently. Like, oh wow, it's like you're smarter. I don't know what it is, but they seem to think you're smart. You have a British accent. I've heard that before. So, the same goes for people in the continent of Africa. Right? If you can do the same, you can fake or learn a British accent. You're gonna help change securing a job a lot more. And that goes really with any that is not United States. Just learn how to develop a British accent, and it'll go a long way for you. Okay. So having your strategy up, having your strategy in place, it's nothing more than this. Just have a piece of paper and write down what do you want, what do you want to make, you know, and you know that by learning what you make now. Money you make now, okay, let's say you make 500 a week, and you want to make 600, right? What jobs help you do that? What jobs do that? The biggest misconception about IT is that once you get started, or it's hard to get a job in IT, but it's really easy afterwards, which is not even anything close to whatsoever. So it's actually a little different. So it's easy to get a job if you have a work ethic and you can demonstrate you're willing to put the work, right? Employers will hire you more so for potential than they will for what you've done. Case in point, two individuals have the same skill, whatever. One has a degree, the other one doesn't, and the one with the degree has zero experience. Meaning they've not done anything, and maybe they had a science degree, right? Let's say everything being equal on the in the States, let's say, not for other countries. But both of them are, one has a computer science degree, the other one doesn't. The same age. And the computer science degree person, they say, well, okay, show me what you've done as far as like your project, right? And they say, well, I've just done my basic project. Okay, well, that's good. Have you done anything outside of your college? Not really. Then you have another person who is self-taught. What is it? C++, Java, but they have a project. They created actually something. Maybe they made their own app or whatever, right? So they're able to talk it through. They're able to talk to a solution, right? So usually, in those cases, right? I mean, sometimes they do still favor the person degree because that's a little check mark they have to have in some cases. But a lot of times they'll take the person that has the knowledge over the person with the degree. because they've demonstrated that they've actually done it and, call it the mark, like, well, that's the word that I like to throw around, right? The mark, like, so you've shown that you can have billing, meaning you can build a product or you can create, a market, whatever it is you make, an app or whatever, right? That's on that. So a little bit about me, right? And I know I used to work in the semiconductor industry. So I used to work for a company called Lam Research, and my job, you probably have seen in your computer, and inside your computer you have like a chip, a wafer, right? Or a chip, really, this chip, and that chip is part of a bigger. They call them wafers, right? It's just a wafer. So on the wafer, you have about 500, or more than 500, so quite a bit more than that actually, but more than 500 die or chips. So that chip becomes the processor in your computer, for all those who don't know. And the process or the technology behind it, right? If you can imagine. So what happens is it's called PCVD, right, or copper deposition, because I work in the copper deposition the fab department, right? Who wore the bunny suits with the orange, not orange, copper, yeah, copper colored bunny suits, right? And we go in the fab, and you have this big tool, right? So the tool, what happens is the wafer. They're like these shiny wafers, right? Have you ever seen the movie with the X-Men, and it's where Magneto has this piece floating on this disc, right? That's kind of what a wafer looks like, right? It's silicon wafer. And anyway, so what happens is they take these wafers, and it's got this food, which is like a robot, right? An overhead robot. And it brings it to the tool. And this tool is probably, it's a big machine, right? It's like 10 feet by 25 feet, something like that. 15, yeah, 10 by 25. So there's about usually 25 wafers per hoop, right? And what happens is that food will load the wafers into the tool. In this case, it's a Sabre, called Sabre, copper deposition tool, basically, right? So the silicon wafers come in, right? And sometimes they go. So the first step is usually like it has this robot, right? It's a robot that like a roast robot picks it up and puts it into the etch. It's an etch. It etches it first, right? Basically, what it does is create an outer film, or etches the out basically of it. So what am I saying? So what happens is when you plate a wafer copper, it'll, just like a penny, it'll migrate over the wafer, Okay. So in order to solve that, what we do is we etch the wafer itself. It's like a really small etch on the wafer. So from there, what happens is they they wash it, basically, right, dry it, and then send it to the annealing chamber. So now, obviously, you're part of like a 6-part process, right, in this wafer. So you can imagine that's the process. So I think I'm skipping. Oh yeah, I'm skipping. So it comes in the wafer. So it comes from the food, goes to the roast robot. It then goes to be etched, right? Right. It just etches around the wafer, right? Then, yeah, I'm missing that, right? Then it goes to copper deposition. So what happens is, if you can imagine, they have this big copper anode. It's giant. It's like maybe 30 pounds, something like that, and it's in this bath of like copper sulfate, basically, right? And it's like a blue color. That's what copper is, and it's liquid form. Anyway, so they put this wafer inside the bath, right, with the copper, what happens is, if you can imagine, you have this, if you can imagine in your mind like a plate, and you turn it upside down and you stick it in the water, right? And just imagine you have voltage, like a positive and negative voltage going through that way. So that's essentially what it is. What's going on is this. You have the copper ions in the bath that are attracting to the substrate. I don't know if that's the right word, but they're attracting to the wafer, right? Okay. So there's other processes. Let me play with the other processes. So some of the other processes, litho, so lithography, right? Basically, what they do is, if you can imagine a house or a building, a giant building, right? 10-story building. So a wafer, what happens is the silicon wafer comes in and they build like a foundation. They usually put tungsten down on it. Then from there, they build like story, you know, first floor, second floor, etc. So what happens is, in this case, it like copper, copper plates it, right? So it plates it with copper. Then it goes to like another section, like a anneal, or not anneal, but a litho lithography section, like another that does that. What it does is it etches little like duo runes, right, on that wafer. So what you have is, if you do it a bunch of times, so basically it's a 6-step process or more, and then you're just one of that part. So what happens is, it comes in, gets plated, then it goes to litho, and then it maybe goes to CMP, which is like a buffer, kind of buffs it out, makes it flat, if you will, right? Then it comes back to you. Okay. What's going to happen is that what they're doing is they're making like first floor through, let's say, 10th floor, right? And when they put litho in there, what they're doing is they're creating like a room, right? So every time they create a room, you take the copper and you're filling in the room, right? So you probably have seen like ones and zeros and process and all that stuff. But that's really kind of all it is in a nutshell, is where you have these different floors, right? So the one are on off, basically, right? All it is just there's a voltage at the end result, where the voltage goes through the wafer and it turns, like floor one has you know, let's say floor one has, a window on the left, let's say, right, and floor two has a window on the right. And when you send a voltage to it, the whatever it's supposed to do, what happens is it turns on floor one's light, but it turns off floor two. So that's 1 and 0, right? On and off. So you can imagine doing that. It's way more than 10 times, right? More than 10 volts. That's a lot. But you don't understand it. Obviously, it's not like I don't understand it, but I kind of do. I did more the tool part, right? So my job was to make sure to train or teach the robot. Teach the robot like a place. It's called PLC. What you do is you teach it and you store position. So what happens is it comes, boop, picks up the wafer, suction on, right, like that, brings the wafer out, then puts it on the place where it etches it. Okay, robot releases suction, comes back and waits, right, and does it all again, and then it plates it or moves to the plating section. So the interesting thing about all that, right, or why am I telling you all that, is in that kind of got me started into the IT field, because on the tool they build these things called recipe. Recipe is nothing more than a set of instructions that will plate the wafer, if you will. It'll go through this process to etch it, and then it'll plate it, and then it goes to like an annealing chamber. Annealing chamber, what an annealing chamber is. I know I'm going to get into the details, but I'll tell you. What an annealing chamber is like a compactor, right? It uses what is it? Helium gas? I forget, whatever. But basically, what it does is suppresses the quote unquote floors, right? So they mash up together, right? There's no gas there in the process, right? Anyway, so during that time, right, I learned about this program called QNX. So QNX is like an operating system, okay, and they use it actually in cars. Probably you don't know that. They use those in cars, and they use it on those tools too. It's a way to interface. So you're just I think a lot of companies that have so we had like pumps, we had spin controllers, like valve spin controllers, we had pumps, we had I forget the name of the company, but Kyonix, I think, or KYOCRA, like that. What it does is it's like an optical scanner, right? So it scans like a bottle, right? And if it gets to a certain level of water or chemical, if you will, it'll turn on or turn off like a pneumatic valve, and that'll do something. For instance, in our case, we had what we call a bath. So the bath was like the solution that you played the wafer. So we had like gamma, A sub, and sub, and they have different, chemical properties to them. But when you plate a wafer, what you're doing essentially is those three chemicals. They have a reason why they're mixed. So then you apply a voltage, and it reacts a certain way. So remember when I was talking earlier with the fills in the floors? So what'll happen is it will actually it'll fill in those little rooms, right? And these chemicals and the voltage applied is kind of how it does it, right? So you probably heard of like when you probably heard on the TV like nano angstroms, right? Like 0.01 or whatever it is now, right? So that's like the width of like your ditch, if you will, or your via. They call it via or gate, I guess, if you will, where the copper connects to the next floor or the bottom floor, or the upper floor. So anyway, so from there, when I worked in that area, working with that, right, and it's interesting because we have pass down meetings, and I didn't know what people look like because they all have the bunny suits on, right? And it was kind of interesting because they had a pass down meeting, and everybody there, like you have like PhDs in chemistry and all this other stuff, right? And your voice is heard. Right? You're just like one of the team, right? Whatever you think about. So the shifts on that, right, were 4 on, 3 off, 3 on, 4 off, right? So I worked 4 days of 12-hour days, and then I was off 3 full days, and then I worked 3 12-hour days, and I was off 4 days, and that was a really, really good job. That's the kind of schedule that is really beneficial for everybody in that matter. You would never need to take a vacation because you never want to. You have 4 days off every week, really, or every other week. So it was fantastic. So anyway, so from there, I went overseas. So I worked as a SATCOM technician. So we how do I say this? So we basically linked up with satellites and got data with satellites, and then we passed along to whoever the customer is, right? Weather data, stuff like that, right? Okay. And then after that, I worked in the Middle East, and I worked as a microwave. So a microwave technician is, you've probably seen it. So you're driving, next time you go outside, right, and drive, when you on the highway, you're going to see like these cell phones, right? So essentially, that's what I work on. So the cell phone tower are like, I don't know, a couple hundred feet, maybe 100 feet. That. So on it, you have a parabolic antenna, right? So it looks like a sideways drum, right? It looks like a drum. And what's going on is, the smaller the dish, okay, the smaller the dish, the higher the frequency, right, and the shorter the shorter the path. So distance from the other microsite. So, for instance, you might have it looks small, right? So you can, if you look at it and you say, "Oh, it's a small dish," right? Parabolic antenna. You're going to know that it's probably like, you know, less than maybe 5 miles away, right? It's really small. The smaller the dish, the shorter the space in between each site or relay, if you will, right? Micro relay. The bigger the dish, the lower the frequency, like C-band or C-band. Yeah, usually C-band. The lower the frequency, the longer the distance, meaning the greater the space between the two different sites. So, in my case, I had four sites, right? So I had two let's see, end point basically, right? And then and two repeaters in the middle. And my job was just to make sure that the signal is going through all. I mean, it was easy, right? But, there was problems with it in some cases. You had rain fade that does affect the signal strength. You have fog will affect it, right? Sometimes even we had like trucks, right? They're hauling something. Maybe it's a mountain, right, or a hill. Let's say it'll cause a little disturbance in the signal, right? And typically they have those everywhere, right? And usually it's like an OC3 or OC. Usually it's an OC3 or OC192, right? Depends on the technology. So a lot of companies make them. Andrews, I think, makes the antennas. Alcatel, Harris, some of the vendors that make the microwave antennas. There's a couple actually certifications. One is the CWNA, like Certified Wireless Network Administrator, right? And that's a big one. So they have also a CWNE, I think, which is like Certified Wireless Network Expert or whatever. And that you get hired mostly if you work in that field, right? Mostly doing stuff like not peak and pull that satellite, but mostly what you're doing is you're making sure that the signal strength is good throughout the repeater, throughout the site. You're monitoring. You're just seeing any BART's head display. They're looking for anomalies. It's really easy to set it up and go, right? If there's any problem, you kind of know what's going on. The reason they use microwave, right? Okay, I'll tell you why. It's cheaper than fiber. So fiber, I don't know what fiber costs, but I know it's definitely a microwave is cheaper than fiber. For instance, you have mountains, right? Mountaintops pointing down to an insight, right? And you're trying to get, bandwidth there, right? Through there, right? And so to run fiber, you're talking go to those mountains. That's crazy, right? All that cost for that? No. So let's just run microwave, right? And you are limited in the amount of bandwidth you can transmit, right? Like I said, OC3 is like 155 megabits per second back and forth. And at the end point, right, you have I forget what it was. I know what it is. It's a radio. It's a radio device. What it does is it converts radio to IO, which is use fiber. Right? Now the interesting thing about all that is this: anytime you see like a microwave tower, right, you're going to see this. It's like this long black tube, right, and it's going to point to this little building, right. That's your waveguide. So your waveguide is essentially how the signal gets out to the antenna and goes over the, through the air basically to the other side. So sometimes that'll get actually wet. So what they have is they have the dehumidifier inside the little shelter basically thing that makes sure there's no moisture, right? Because that'll cause a problem as well. Usually, like cell phone companies all use this technology, by the way, now. Who else uses this technology? A lot of your temporary site. So like maybe there's an event, there is a concert, right? Sometimes they'll set up like a relay, microwave site, like bandwidth. Like maybe they need to have a cell phone coverage, right? So they'll bring in like a microwave dish or microwave attached to the cell phone tower, and that'll bring it from somewhere else. Sometimes you'll see these going on the road in like rural areas. So for miles and miles and miles, you won't have a signal, satellite or cell phone signal. So you see like the cell phone tower, it'll have like a parabolic antenna on it, and that's how they get the bandwidth to that site. Usually at these sites, they have like generators, just like fenced in, right? Generators. They'll have backup power, basic, right? And they have usually alerts, like it's if the door opens, there's an alert that's sent out, like they're gonna trigger SMB or SMNB trigger or whatever. They'll have like if it goes down or the generator turns on, there's a signal. There's like a trigger, through the signal, and it sends out to whoever is on site or who's on call, and they go out and look at it. Okay, this is what's wrong. Right? From there, I went and I studied in India. Actually, so I lived in Bombay, and I studied CCIE. Actually, I didn't get right, but I did study for it. I didn't get it for it. I think really I didn't have like the systems administration background then, and I think that was my major hindrance, right? So I saw the dollar, right? I saw the dollar figure. So, oh yeah, I'll just get a CCIE. It's too easy, right? Not knowing that that's not really the case, right? So that that's not even the case at all, right? I mean, it's a hard cert to get, right? I did take the lab. I didn't pass for, but it is a hard cert to get. That's one of those certs that, like, if you got a CCIE, right? You're good. It doesn't matter where you're from. You could live in any country, right? You have a CCIE, you're good. You may not get like top dollar anywhere, right? But you could go to anywhere. So, like, let's just say this for instance, like if you're from India, right, and you get a CCIE, your destination is going to be like, ideally, right, would be like Singapore, because they'll pay you quite a high dollar. If you're like from the African region, right, continent Africa, you can go to Brazil, you can go to Singapore, you can go to Dubai and work there as a CCIE. You're going to write your own ticket in some cases. Right? If you're from the European Union, you can work in European Union with that certification. If you're Asian, like you're Chinese, you're from Thailand, Vietnam, Malaysia, Laos, Cambodia, if you get a CCIE, you definitely can write your own ticket in those. So here's the thing, right? Like a lot of those countries only have a limited amount of CCIE, even now. Right? I think some countries, like China, has 2,000. U.S. has like 5,000. India has only 1,000, I think. But these other small countries, like Thailand, might have maybe 30. Dubai or UAE might have 100. Singapore probably has 100. And so you're gonna be able to get a job with that. I mean, it is like I said, it's something you have to dedicate long for, like a year, right? That's usually nobody usually gets it and says work because what it is there's a factor of failing. But most people that take their lab, CCIE lab, they fail. They fail that. Most, like 90% of the people that take it first, and then they take it 2 or 3 times, right? But when they do, they're good to go, right? So from there, I worked in so I worked in the Middle East, right, for a number of years, and during that time, that was great. I've been to Egypt, I've been to Lebanon, I've been to Qatar, Kuwait, Bahrain, and during that time, it was great. It was a nice enjoyment. and I enjoyed it. Right? It's a little different than anywhere else. I mean, driving, thing. But the aspect I liked about it was you're able to like go out and talk to folks, all the time. Just go and talk and have a good conversation and just like really enjoy what they're doing. And it really is a lot more, I'd say, friendly, or I'd say actually family atmosphere. I would say because everybody there is looking to make money, right? They're there for a purpose, they're for a reason. So they have to really genuinely be friendly because they have to get along with everybody. Right? There's the benefit of that is you're gonna meet lifelong friends there, right? And so during that time, I learned system administration. I remember the first time. So Jimmy Rucker told me. I asked him this, right? I said, "Hey Jimmy, how do you get into this server?" He was talking about towards whack, which is like // into a computer, right? I didn't. He's like, "Oh yeah, type // right?" What are you talking about? Then I remember Wayne Mills. Wayne showed me how to do Active Directory. Actually, Wayne showed me how to do Active Directory, how to get it working. I didn't know, no idea, right? So it was a good experience for me there. And that was it was just, so if anybody out there actually wants to work in the Middle East and you're thinking about it, I would say that Dubai is a nice or city, not a city to live in. Qatar is a nice city to live in. Bahrain is nice, right? Like I said, Doha, Qatar is a nice city to live in. There's a lot of nationalities in Doha, Qatar, or Qatar. You'll find anything and everything you want. The food there is pretty nice. Of course, I'm fond of shawarma, chicken shawarma, and how they make it. So there are different versions of the shawarma, right? You have the Gulf shawarma, which is like more like a red shawarma, and then they have like the Lebanese shawarma, which I'm impressed with that actually. Which that one I like. What they do is they take this naan bread, yeah, or naan bread, and they put that down, and then they put it's like this garlic paste, right? And they put chicken. I call it, in Arabic, I think it's dijaj. Anyway, or no, it's Syrian. Yeah, they put chicken dijaj down, and then they put those bread. Then toom is what the garlic is, right? And then they put chicken dijaj. Then they put pickles, and finally they put French fries. So that's a shawarma, right? That's like the real deal Holyfield shawarma, right? Or are you those individuals out there that know that? It's not tahini, right? I mean, I get it. Tahini's, good and all that. Right? It's not my thing. It's not my thing. And yeah, so anyway, so eating shawarma was like an awesome pastime for that. They stay out late, right? So Friday night, everybody's out late talking, hours. So you have a meal out there, right? And you're gonna just eat for hours, and you don't eat for hours. You just talk, eat, talk, right? Have chai or tea, right, or whatever. It's just a good fun time. It's a lot different than the lifestyle days. Okay, so from there, I worked in. Of course, I worked in the satellite communications industry as well. So satellite communication is nothing more than like iDirect, right? And a couple episodes ago, our last episode actually, we had Brandon on. So we talked a little bit about the iDirect TV, right, with your satellite antenna. So if you can imagine, you have the Rec TV that shoots a signal to this satellite in the sky, in space. It's like 36,000 miles or whatever it is away, something like that, right? Anyway, it'll shoot a link or a signal to the satellite, right? And the other end, that satellite will take that signal and then shoot it back down to what they call a hub site, which is this gigantic antenna, probably like 60 60 feet in diameter, right? And on that side of the antenna, they usually have the internet connected there, right? So all of your internet comes from the hub side. So the receiver is usually it is always actually the direct TV antenna in your house, right? You're sending and receiving from that endpoint, that hub, somewhere else, in whatever part of the world, right? So that's how you get millions and millions of customers to serve the internet in remote locations at one time. HughesNet, I think, is another one that does that. That's how you do that. That's how you get that done. That's a big industry, actually, right? So there's a company called I know I've talked about it before. I believe it's Sitel or Transcom, I believe it is. I think it's Sitel. What they do is they actually provide customer support for customers that use DirecTV, right? Or HughesNet, I think it is. So, Viasat, sorry, is the name of the satellite or antenna that they use, and they provide customer service. So that job pays roughly, I think, $13 an hour to start, and you get 5 weeks of training, and you're able to do that, and you can learn as you go, right? You don't know anything, get that job working for Sitel. Moving on. So from there, I got into backups. That's how I actually got into backups. So when I talk about backups, I started it at nothing for backup. I didn't know anything about backup. I need backup software, right? So I know I have a couple courses I have a course on Udemy, I have a course on Teachable. I have three courses on Teachable. I have 3 courses in Udemy. And first one is Introduction to Commvault, or 10. The second one is Get a Job in Tech, make 100K or whatever it is, which is, that's actually true, right? The course I teach you about is actually how to start to finish. So you don't know anything about IT whatsoever. You just watch the course, 20 hours, you're good. It is a little, the audio is kind of like a little bit, I know, it's that, but nevertheless, it is a pretty important. It does, what I do in my courses is I leave the error in. So I make an error, I make a mistake, I leave it in, because when you create the course, or you do the course yourself, the things I'm talking about, you're going to have the same problem, and you're going to want to know, like, how did Gary fix this, right? Because you don't want to go to the Commvault website or Microsoft website and ask, how do you do this? You may not get the answer you're looking for. So instead, I just leave the error, right? I don't edit them out, I leave them in. That way, you're benefiting my thinking, and because you're going to run the same thing, 1,000%. Commvault, I mean, Commvault is it's a piece of software that sometimes works, sometimes doesn't. Install it does work most of the time. I'd say 99% of the time it does work in a production environment. Sometimes they do have some. That's how I learned. That's how I learned actually back in that field. So, and then from there, I learned Linux. So from the backups of Commvault, I learned Linux. I learned SQL. I learned Oracle. I learned SharePoint. I learned Active Directory, and I learned Amazon AWS, or the cloud. Right? I learned other technologies like storage, NetApp, storage by OpenFiler, which is a free one. I learned Data Domain, which is a EMC or Dell product. I learned NetBackup, which is a competitor. So once you know one backup system, you know them all, because it all really work the same. Right? There are different differences in a couple of them, but really they all work the same. And that has benefited me. So the Cisco knowledge that I had prior to backup actually helped me out, because in NetApp you have to be able to really understand the routing. You have different networks. You have 2 networks on a comm server, and you have a backup network, and you have a production. So you have to be able to distinguish the two. You have to be able to send traffic out to the backup network versus the production, as well as working with NetApp, which is a storage. So they have a cluster storage in there. I know a lot of this stuff is just like way over your head, right? Because you're like, what the heck are you talking about? And it's just me talking about all that type of stuff. So anyway, the bottom line for this, right, is whenever you figure out, you decide what you want to do with IT, right? You say, okay, I want to do this, right? Once you decide, you're good. Most of it's just like deciding you want to do it, right? You're gonna find in IT that you're always learning. I know a couple of some of the channels have said that, but it really is true. Actually, you're always learning in IT. You're always going to be learning. It's a nonstop, never stop. And the reason it's like always learning because things are always changing, things are always adapting, and to be marketable, to have a skill set that's marketable for the future, you want to always learn, and IT really makes you learn more, right? That's 1,000%. That's exactly how it is. I will say also, right, the more knowledge you have about all of this, the better chances you are going to get a job because you've already run into some of the similar issues, and companies will say, "Wow, you have a good experience here because you've already done it. You've had those Friday night. Oh man, I got to make this work, otherwise, job on Monday. So I can't have this stuff go down the night. I need to have it work." And you'll kind of have those experiences when you work in IT, and you'll have some of them not be that extreme, but in your training environment. So the good thing is to like when you train, if you make a mistake, it's fine. Just push through it and then get it because those are the stories that you talk about when you interview for your job. That's the kind of stuff they want to say. Oh yeah, tell me about a time when you had an issue or whatever it is they tell you. However, so yeah, that is good stuff there. So thank you very much, everybody, for listening to the podcast, and have a great day.